Welcome to Maths with Bob. Today we're looking at solving trig equations, and these ones are a particular type of equation, a trig equation, and I'm just going to show you. First of all, let's actually just have a look at the trig equation. Okay. Okay, now what do we notice about this trig equation? Well, hopefully we can see that there's a 2 theta and a theta. Now, our basic idea is we need to unmix our angles, basically, if you like, or drop them to the lowest common angle. In this case, it'll be theta. So we need to expand that 2 theta, that cos 2 theta, using the cos 2 theta results and drop it back into an expression involving, I would say, cos theta. I mean, we could go to sine theta, but you can see we've got a 4 cos theta minus 3 on the right-hand side, and we're going to need to, if you like, unmix the cos 2 theta into cos thetas. And as you can imagine, we're going to get a cos squared theta result in there, and we're going to, well, end up with a what's called a quadratic type trig equation. Okay. So the first thing to realize is when you look at a trig equation is, does it have mixed angles? Now, what are the mixed angles? Well, yes, here, let's actually have a look. The mixed angles would be, okay, this one, there's a 2 theta there, a cos 2 theta, and you can see here a cos theta. Okay, so they're what's called the mixed angles. Okay, so we now have to, if you like, solve these type of equations by unmixing those particular angles. Now, so how are we going to do it? Well, let's have a look. First up, we'd write, okay, our cos 2 theta as, let's have a look, cos squared theta minus sine squared theta. Okay, that's okay. That's going to equal 4 cos theta minus 3. We then rewrite sine squared as 1 minus cos squared, and then simplify the expression. I'll just do that in one step here. 2 cos squared theta minus 1. Okay, that's still equal to 4 cos theta minus 3. Now, you'll notice something too, which is right good, because we do actually have this domain restriction. And you might remember, this is a great thing to have, actually. This is called the domain restriction, okay? We're going to solve this particular trig equation for theta between 0 and 2 pi. That means we don't have to do what's called the general solutions, okay? So we're going to have a domain restriction on our trig equation. Okay, so let's actually keep going, okay? Expanding out this expression, we have what? 4 cos squared theta minus 2. Let's bring it all over one side in one go as I'm running a little bit out of space. So I'll bring the 4 cos theta over, minus 4 cos theta. Bring the 3 over, and we'd have a minus 2 plus 3, so it just becomes a plus 1 equals 0. Then I would try and factor that. If I couldn't, I could use the quadratic formula on it. But you might be able to see that that is just 2 cos theta minus 1 all squared. That's equal to 0. Okay, therefore, you can see that 2 cos theta minus 1 would be 0. Therefore, if you like, cos theta would equal a half. Therefore, the solutions would be, okay, now, what are the solutions to a half? Well, you might remember our, always draw up these little triangles, root 3, 2, 1, pi. Down here, that's 60 degrees, which is pi on 3, and pi on 6 up in this top corner, 30 degrees. And you can see pi on 3 would be one solution, and remember we always have to draw up all stations to central. We know, okay, the base angle is here and here. So our solutions would be for theta, pi on 3 in the first quadrant, and 5 pi on 3, okay, in the fourth quadrant. Okay. All right, let's have a look at example 2 now, where we have a bit more of a complicated example. Okay, here we have our second example. We've got, let's have a quick look at that one. Okay, here it is here. Let's actually have a look at it a bit larger. Okay. Now, we've got cos squared theta equals 2 cos squared theta on 2. Now, this is an example of a mixed angles you might be able to see there's a theta and a theta on 2. So we now have to reduce this to the lowest common denominator in terms of angles, which will be theta on 2. So we are going to need to replace that cos squared theta with its half angle results, if you like. Okay, so let's try that. Okay. All right. So how do we do that? Well, you might remember cos 2 theta was equal to cos squared theta minus sine squared theta. Therefore, cos theta. Okay, so let's actually do this. Okay, so we now have, what is cos of theta? That was what? Cos squared theta on 2 minus sine squared theta on 2. Okay, that is the cos, if you like, theta result in terms of half angles, but we now are squaring that, and this is equal to what? 2 cos squared theta on 2. Now, one of the great things again is you can see here we have a domain restriction. Okay, this is our domain restriction here. Okay, and you can see this is now in terms of angles. That's supposed to be 360 degrees. So we need to put our answer in terms of degrees. The previous example was in radians, so we put our answer in radians. So just look for the domain. That will give you an indication, if you like, a pointer to how you're going to write your solutions. In this case, we need to put the solutions for theta in terms of degrees. Okay, now what are we going to do now? Okay, well, we've got sine squared there. We need to write it in terms of cos squared, so we'd then just write that as 2. Oops, let's actually go back to the right pen. Okay, write that as 2 cos squared theta on 2 minus 1 all squared. Okay. Okay, that's not too bad. Now it gets a little bit more complicated. What I did was I just let u, okay, just on the side here say, let u equal cos squared theta on 2. Just to simplify things a little bit. And then what do we get? We get 2u minus 1 all squared is equal to 2u. Okay, so we need to expand all this out. What do we get? Therefore, what? 4u squared minus 4u. Okay, so putting the 2u across. Okay, minus 6u plus 1 is equal to 0. Okay, we're now going, you can see here we now have a quadratic in terms of u, and you can see that when you do the quadratic you end up getting what? U is equal to, I think it's, when you simplify it, 3 plus or minus root 5 over 4. 3 plus or minus root 5 over 4. Now, okay, so that is u, okay, and u is equal to cos squared. So basically cos squared, theta on 2 in fact, is equal to 3 plus or minus root 5 over 4. So what is cos theta? Okay, obviously, cos theta on 2 in fact will be equal to the square root of this, okay? The square root is 3 plus or minus root 5 over 4. Now, okay, so we'd have a plus and minus as well at the front here. Now, okay, so when you actually evaluate this, if you take the 3 plus root 5 over 4, you'll end up getting basically that that won't work. If you take the negative case, I think you get, basically you end up getting theta on 2. Let's actually rub some of this out. Okay, so let's just rub some of this out here. Okay. Okay, so what will you get? Well, you end up getting that cos theta on 2 is equal to basically plus or minus roughly about 0.437. 0.437. And you can see here, if theta is between 0 and 360, then theta on 2 would be between 0 and 180. So we need to obviously take the positive case. We end up getting what theta on 2 is approximately equal to about 64 degrees and 5 minutes. Okay, therefore theta should be what? 128 degrees, say 10 minutes. This is approximate. Okay, so you can see this was a bit of a harder example. We have to watch out for the domain restrictions again. We dropped it down to its lowest common denominator, theta on 2's. Then obviously we have to affect or implement half the domain, if you like, because theta is between 0 and 360 and theta on 2 would be between 0 and 180. Okay, well, thank you for watching, and bye for now.